All right, today we are going to be looking at solving inequalities. So we'll see what an inequality is and how to solve it in a couple of different ways. Okay, first of all, an inequality is basically it's like an equation, but instead of having an equal sign, you now have a less than or a greater than sign. And you could also have a less than or greater than sign with the equal still underneath it. And essentially, if you have an equation like this, or an inequality, really, I should say, you can solve it like an equation. We're going to see we have to be careful just a little bit, and we'll see that in a little moment. But yeah, let's just start with solving this one like an equation. So how I might do this is I might move the 2 over. So add 2 to the right-hand side and turn that to 15. And then divide by 3, and I could say x is less than 5. And we can test that out. If you were to plug in test x equal to 4, on the right-hand side, you'd have 3 times 4 minus 2, less than 13. 12 minus 2 is 10, which is less than 13. Okay, so that looks like it works. Okay, let's go with this next one. So 5 minus 2x greater than or equal to 1. So let's move the 5 over, and we will have negative 2x greater than or equal to 1 minus 5, which is negative 4. And then let's divide by negative 2. And so we will get x is greater than or equal to negative 4 divided by negative 2 is 2. So let's test something. So what's greater than or equal to 2? Let's do 3. Okay, and let's go to that original equation there. So if we do 5 minus 2 times 3, we get 5 minus 6 is negative 1 is greater than or equal to 1. Wait a second. Yeah, if you take a look at that, you will see that it didn't quite work out. I tested out a value that was greater than or equal to 2, and it definitely doesn't satisfy that inequality up above. So what happened? What happened is we need to be careful dividing or multiplying by a negative. That's going to be the key thing, and really the main difference when dealing with an inequality versus an equation and solving it like this by a negative. So what you'd actually have to do in this case is when you get to, let's say, this step here, the 2x, negative 2x greater than or equal to negative 4, what you can do is divide, but then flip the sign. And so now you will have x is less than or equal to 2. So flip sign. That's going to be the key thing. And then it will work out. So if you were to choose x equal to 1, well, 5 minus 2 is 3, which is greater than or equal to 1. Okay. And let's get that down onto your note there. So yeah, when working with inequalities, if both sides of an inequality are multiplied or divided by a negative value, again, that's the key thing. Multiplied or divided, so you can still add or subtract like we did before. It's just the multiplication or division. And then you just switch that inequality and flip it around. So that's what we need to be careful of. But other than that, you can treat it pretty much like a regular equation. Okay. So let us continue to some other inequalities. So these are ones that we can't just rearrange for x and get an answer. These are ones where we're going to have a full polynomial, and we're going to see how we can do this. So what we're going to do is we are going to graph -2, x plus 2, x minus 4, x minus 3. And this is just using what we did last unit. So we're going to do things like, what are the x-intercepts? Where the y-intercept? Okay, so the x-intercept is x equal to -2, 3, 4, and I'll just say all order 1. Do this a little bit more condensed. The y-intercept, well, not multiple, just one. Substitute in 0, so y is equal to -2 times 2 times -4 times -3. And if we do that, that's going to give us -48. And the end behavior, well, we can see that the graph is negative and it's odd degree. So it's going to be from quadrant 2 to quadrant 4. Okay, so just quickly going through those things. So let's just plot things out. So we'll plot out -2, 3, roughly making this to scale, 4, and -48. Okay, that can't be perfectly to scale. We'll just put it down here. So let's draw this graph now. So we're going from quadrant 2, going down, going through the y-intercept. Oh, let's try that again. Let's just make it a little neater. And I'll do it in a different color than what I drew the points. Not the nicest of graphs, but we have something there. Okay, so the question then is, how does this graph help us with the question? So the question says, solve for when -2, that whole polynomial is greater than 0. So what are we actually solving for? So what we want is where is the graph greater than 0? That's essentially what we want. And let's just add it down here, solving for. If we want the graph to be greater than 0, well, that means for the y value to be greater than 0. That's what we're talking about, which means, well, if the y value is greater than 0, we're looking at above the x-axis. So when is the graph above the x-axis? Okay, so essentially that will mean this initial area here, that's above the x-axis, and between 3 and 4. So those two areas are both above. And so we just need to write down, well, what are those areas? So, well, the first part is all the way to the left up to -2. So we can say that x is an element of -infinity all the way up to -2. And we're not going to include -2 because -2 is on the axis itself, so it's not above. So we're going to use an open bracket. And since we have another piece, we're using that union symbol. And then between 3 and 4, both of those with open brackets. Okay, and that's really what we mean when we're trying to solve an inequality. We're looking for the regions where the graph is above or below the given value. So in this case, above 0. Okay, let's take a look at this one. X cubed plus 4x squared plus x minus 6. That's less than or equal to 6. So we want when it's less than or equal to 0, we want below or equal, because now we have the equal sign underneath, equal to the x-axis. So include roots. Okay, so how are we going to solve this? Well, if we want to do it like the one we just did up above, We can draw the graph. That's what we have on our page here. So let's draw the graph, which means we need to get it factored. So we need to factor this first. And yeah, everything in this unit really does come back to factoring all these different kinds of questions. So what I'll do is I'll just label this P of 1, or sorry, not P of 1. That's what we're going to test first is P of 1. We'll call it P of X. And factors of 6 are 1, 2, 3, and 6. So let's just test P of 1. And we get 1 plus 4 plus 1 minus 6. And what do you know? That is equal to 0. So x minus 1 is a factor. Okay, and so then we can do a little bit of division. And we'll just do synthetic division. So I'll have the 1 on the outside, 1, 4, 1, negative 6. Bring down the 1, and just go through the synthetic division process like we normally would, and you will end up with x minus 1, x squared, plus 5x, plus 6. That is going to be less than or equal to 0. We still want this to be fully factored, so just make sure to factor that quadratic part, and it will factor nicely as x plus 2 and x plus 3. Okay, so that's now what we're trying to solve in its factored form. Okay, so the roots, the x-intercepts, those are x equal to negative 3, negative 2, 1, and they're all order 1. What else do we want? We want the y-intercept. So the y-intercept is going to be y equal to substitute 0, negative 1, or just look at the standard form, negative 6 there at the end. So it's just negative 6. And the last part is, of course, the end behavior. So it's a cubic that's positive, so quadrant, it's going to go from the bottom left to the top right, which is, I think, quadrant 3 to quadrant 1. Okay, so let's draw that out. So we're going to have negative 3, negative 2. Try to do this kind of to scale. 1, and negative 6 would be pretty low then. So I will label things here. Negative 3, negative 2, 1, and negative 6. Okay, and so let's follow our end behavior, do something like this, and like that. Okay, it's not the greatest of graphs. Let's try that. We'll just try it one more time. But that's the idea, is just to get it through those points and make a nice curve like that. Okay, so there we go. We've got the graph. And well, let's go back to the question. It is looking at when is it greater or less than or equal to 0. So again, we're looking at when it's below or equal to the x-axis. So that's going to mean we're looking at this first portion up to negative 3. We're looking at the second portion all the way from negative 2 to 1, and that's it. So let's write down our solution down here. So let's write down the solution as x is an element of, and we're starting from the left, so negative infinity all the way up to negative 3. This time, since it's less than or equal to 0, so that means it could reach the axis, we can do a closed bracket there. We have another part, so we're going to do the union sign, and then between negative 2 and 1, and again, those roots are reached, so we can do it as closed brackets like that. And there we go. We have that answer, which is stated through that interval notation. Okay, So graphing it is one way to solve these kinds of questions. Another way is to just use a number line, and this can be, I tend to find, a little bit more efficient, because really the key thing we're making use of with the graph and what you might be able to see is the only time the sign is going to change from positive to negative for these polynomials is at the roots. So as long as we check where the roots are and check what's happening between the roots, well, then we can determine where the graph is positive and negative. So let's write that down. So the change in sign always happens at roots, the x-intercepts. Okay. So then just focus on the sign between roots. We don't even need to know exact values, and you'll see what we mean by that when we go through this. So what are the roots? What are the x-intercepts? Above, we have x equal to -9, -5, and 6. So let's draw out a number line with those values. Okay, so we've got our line here. I'm just going to write out -9, -5, 6. And what are we going to do? We're just going to use a test value to check the sign between or to check the sign in each interval. That's what we'll call it. Each interval just being between the roots. So like from the start -infinity to -9, -9 to -5, so on and so forth. And I'll even include the infinities on there. So in each interval. Okay, so for the test values, I'll just write them directly on the number line. So with the test values, you don't even need to actually determine exactly. So when I'm doing a test value here, to the left of -9, I could just pick something like -10. All I care about is the sign of our answer. So what is the answer? We'll take a look at what happens when you plug in -10 into the polynomial up above. -10 plus 9 is going to be some sort of negative value. -10 plus 5 is also a negative. -10 minus 6 is also a negative. I'm multiplying 3 negatives. Well, what's the answer going to be? Negative. Just going to circle that just so that we see that's a negative sign. Okay. And again, it doesn't matter what it's actually equal to. All that matters is it's negative to the left of -9. And that will be true for that entire interval, because it can't change to positive unless you reach the root. Okay, and just repeat that process for the other intervals. So let's pick a number between -9 and -5. Let's do -7. What is going to be true about each of these factors? Well, -7 plus 9 is positive. -7 plus 5 is negative. -7 minus 6 is negative. So two negatives become positive times the positive makes this positive. Which, again, we're thinking greater than or less than 0. That's greater than 0. All right, so then continuing on. Something between -5 and 6, I'm just going to choose 0. So if you were to plug in 0, you'd have 9 times 5 times 6, or just looking at the signs, you'd have a positive times a positive times a negative. Which, if you have just one negative sign, will lead to a negative final answer. And let's repeat that one more time. Something bigger than 6, let's do 10. It doesn't have to be the next number over, just something easy to work with. 10 plus 9 is positive. 10 plus 5 is positive. 10 minus 6 is positive. So what's the final answer? It's positive. So there we go. So we have tested all the intervals. So now we just look at, well, what do we matter, or what do we care about? It's the two positive intervals. So therefore, x is an element of -9 to -5, and just be careful about the kinds of brackets. So we are strictly greater than, so we're not including the roots. So -9 with an open bracket, -5 with an open bracket. Union 6 to infinity. And there we go. So yeah, this is typically the method I like to use. It's in a sense like a graph, but we're just not going through the full work of drawing out the graph. We're just focusing on the signs of the graph by using the roots and what's in between the roots. Okay. So let's go through these next ones. Try them out yourself first, but we're going to try them with a number line. Okay, so identify the x-intercepts. So the x-intercepts are x equal to, I'm going to go from least to greatest, so -5, -2, 3, 6. The reason being is now when I draw the number line, I'll get it in the right order, just from the start. So we're going to start from -infinity and go to -5, then -2, then 3, then 6, and positive infinity. All we're doing now is just like what we did before. We're just going to test a number on each of those intervals, check if it's positive or negative for basically each of the factors, and then see what's the final answer. Is the final answer positive? Is the final answer negative? And that's the process. So I'm just going to write down some numbers. -10, between -5 and -2 is maybe -3, between -2 and 3 is 0, between 3 and 6 is 4, and between 6 and infinity, any big number, let's just do 10. And now let me just go through and check the signs. So what is that polynomial going to multiply to? Well, if we plug in -10, it's going to be -10 minus 6, so that's a negative. And this is where we need to be careful with this one, because you will notice that some of these factors have exponents. So just take into account what happens if I were to take a negative number and square it. Well, it would become positive. What would happen if I take a negative number and to the power 4? It would become positive. And the last one, a negative number cubed, that stays as a negative. And, well, 2 negatives and 2 positive make a positive final answer. So, yeah, be careful of the exponents. Okay, let's keep going. So if I plug in -3, what happens? The first one's still going to be negative. And the next part is positive because it's squared. The next one's positive because it's to the power 4. That will be the case for all of these different intervals. And -3 plus 5, well, that's positive now. To a positive or to an exponent 3, we'll keep it positive. So that will be negative, that interval. Let's keep going. So you see, it's a little bit repetitive plugging in these numbers, but it can get you the sign fairly quickly for each of these sections, rather than going through the whole graphing process. Okay, so plugging in 0, you still have a negative to start off with, and then you have a positive, another positive, and then 0 plus 5 is also positive. So you still have negative there. So you can see here 2 negatives beside each other. That can happen. And plugging in 4 minus 6 is still negative. Then you have the squared part and the power 4 part. Those are positive. And, well, 4 plus 5 is positive. So again, the same thing, still negative. And so next we're going to look at the 10. And now all the different factors are going to be positive. So everything being positive means the final answer is going to be positive. Okay. So now let's get to our final answer. So our final answer, you can see we have basically the 3, we're looking at less than 0. So we have the 3 middle intervals. You may be tempted to just write, well, -5 to 6. That's very close, but we just have to be careful because the question is looking for strictly less than 0. So we still have to skip over the actual root. So we still have to skip over -2, still have to skip over 3. So we do need to write it as separate intervals. So -2 to 3, and then union 3 to 6. And there we have it. And lastly, let's go through the final one. X cubed minus 6x squared plus 9x. Well, this one, it's not in factored form. So let's get into factored form. As you can see, we're always looking to get those roots, those x-intercepts. So that's going to be a big thing in these kinds of questions. So factor first. And if you factor it, well, you can common factor out an x. So x times x squared minus 6x plus 9. And then if you factor x squared minus 6x plus 9, take a moment, try it out yourself, but you should be able to get x minus 3 times x minus 3, which is just the same as x minus 3 squared. Okay, and so get your roots or your x-intercepts. So you have x-intercepts, roots of 0 and 3, and so then make your number line based off of that. And yeah, this number line technique, not only is it handy for this particular unit, it's something that we use quite a bit actually the further you go into math, whether it's just calculus, the next math course if you're taking that. We end up using number lines a lot in there too. So it's a handy skill just to get used to. And with these number lines, usually it's just testing a value and typically just checking for signs. So you're not too worried about the actual number. So I'm picking some number left of 0, so something smaller than 0. -1, why not? Between 0 and 3, 1. Bigger than 3, 10. Again, the specific numbers don't actually matter. And so I'm going to get a negative times a positive, because you have, well, -1 times something squared is positive, which is going to give you a negative answer. When you plug in 1, both parts are positive, so you get a positive answer. And when you plug in a 10, everything's positive again, so you get a positive answer. And we want, when is it greater than or equal to? So we're looking at these two parts where it's positive. And in this case, because we're looking at greater than or equal to, we can include the root. So we can, instead of splitting up the interval as like 0 to 3, 3 to infinity, we don't need to do that. We can just go straight from 0. And since we're including it, we're making it a closed bracket all the way to infinity. And that is our final answer. Okay, and that is a look at solving inequalities. Really, for most of these questions, a number line will tend to be the way to go. Or you can go through the graphing process and use the graph visually to solve these kinds of questions.